Here are your notes for 5.3, and it's going to cover properties of the trigonometric functions. So to refresh our memory, okay, 5.1, we were introduced to radians, right? Degrees, minutes, and seconds. 5.2, we started talking about the unicircle and how to use it. And so 5.3 is going to talk about some properties. And so to refresh our memory, we're going to fill in this box here with some definitions. The key thing is it's telling me I'm on the unit circle, all right? So what that means when you know you're on the unit circle is your radius equals 1. So some definitions are, we found in the last section, that sine of theta is always your opposite over your hypotenuse. However, my radius in the unit circle is 1, so that's why we get, no matter what, sine of theta are my y values. That's only, I have to make sure this really clicks, only when you're in the unit circle. No other time is that the case. And I'll show you examples of when you're not on the unit circle. So cosine, well, your definition of cosine, which we learned when we first met, is adjacent over hypotenuse. And actually here, let me go ahead and give us a circle. So, well, not the best circle, but here you go, and you have your angle is here, right? Well, this is, let's see if I can, that's your R, this is your X, this is your Y. So if you're doing cosine, it's adjacent, so that's X over your hypotenuse. Well, my hypotenuse is 1 when I'm in the unit circle, so we just get out X. Okay, well, the next definition is tangent. Well, that definition, I want to make this a little, maybe I can zoom in. That definition is opposite over adjacent. So in that triangle, that would be y over x. Then you have 3 other trig functions that we don't use that often. We definitely use these 3 most often, and that is the reciprocal functions that we discussed. So the reciprocal for sine is cosecant. So it's just the reciprocal of this, so that would be 1 over y. Just reminding you, though, we're going to say y cannot be 0, and that's because you can't divide by 0, we get undefined. So we're just going to state that. My reciprocal for cosine is secant, and so that reciprocal for this ratio would be 1 over x. But I'm going to state x cannot be 1. I'm so sorry. 0 I meant to say. Because you can't divide by 0. And then my reciprocal for tangent is cotangent. So that reciprocal would be x over y. And once again, we are going to state y can't be 0. And you know what? I should have done that with tangent. So we should say x can't be 0. Again, because we can't divide by 0, it would be undefined. So these things are known as functions, all right? And you hopefully are coming in here hearing that word functions before. It's going to keep being drilled into your brain. And the idea of a function is for every input, you have exactly 1 output, all right? So it passes that vertical line test, all of those things you talked about in algebra before you came into 112. So some notation is f of theta equals, and I'm going to talk about sine as a function. Well, this is your input, okay? And this right here is known as your output. Now, just to refresh our memory, your domain is talking about your input, and your range is talking about your output. And so for us, I'm going to go ahead and pull up this unit circle. I'm going I'm just going to drag it a little bit down. Okay, so for sine, our domain, that is going to tell us all of the values I can put inside this function. So I like to think of like a soda machine. So can I put in quarters? Can I put in dollars? Can I put in credit cards? Like anything you can put into this machine. So for our machine here, it's thetas, it's angles. Well, it looks like we can put in 30 because we get something out. We can put in 45, we get something out. We get 60, we get something out. And so forth. We put in all these angles. I'm not getting any undefined. It's, still being something. I'm still getting something out. Now realize also, there's all these angles happening in between here. They just don't give us these exact answers. They would be irrational, so we don't list them. But there's all these angles happening all between here. And I could go negative, right? I could say, oh, right, if I put in negative 30, I get out negative 1/2, so that works. So we have, our domain is negative infinity to infinity. We can put in any angle we want. We can put in a positive angle, it works. We can put in a 0 angle, it works. We can put in a negative angle, it works. The other way you could say that is all real. All right, I'm going to get rid of it. Well, I guess I need it still for range. Now our range is talking about the outputs. So now what I'm going to look at, get rid of this stuff. I'm going to look at all of my y values since I'm only looking at my sines. So, it doesn't look like I get out 100, right? It looks like the biggest I possibly can get is a 1. And because I keep going around, it's going to give me out values here. We just don't know them off the top of our head. I hit that 1, and then I start coming down again. I hit that 0, and I keep coming down and down and down, so I hit a negative 1. So for this one, we get negative 1 to 1 is our range. Now to refresh your memory, we use brackets because it can be those values. We use parentheses when it can't. For infinity, we always use parentheses because it's a concept. All right, so we're never going to use brackets with infinities. So now let's talk about cosine. So our function for this, we could name it with a different variable, g of theta will spit out cosine theta. Well, we could go back to the unit circle, but with theta, that's just our angle. So domain is theta, and our range is our output. For us, it's g of theta now. Or we could say cosine of theta. Okay, so angles. Were there any angles on that unit circle that you put in that spits out undefined for cosine? And no, they all work, right? It's the same idea as sine. So our domain is all real. Also, when we get into the next section and we start graphing these, maybe visually it will sit better with you as well, figuring out the domain and range. And same deal here. The lowest my cosine gets is negative 1, and the highest it gets is 1. I'm just going to bring back that. So it's very messy. But if you look at, for cosine, I'm going to get rid of all this stuff. For cosine, we're looking at the x's, right? Okay. And then I hit 0, and then I start getting negative numbers, and I hit negative 1. And I start going back up. I hit 0, start going back up, and then I hit positive 1. So that is why we go from negative 1 to 1 for your range. Now tangent. I'm going to bring back this messy thing again. I'm going to erase everything. Now tangent, remember, your theta is your domain. And remember, tangent of theta from above, the definition is y over x. So if I divide this by this, I get something. I don't care what it is, but I get something. So 30 degrees works. If I divide this by this, I get 1. So 45 degrees works. I divide this thing by this thing, I get something. It works. If I divide 1 by 0, I can't divide by 0. So that is undefined. So what that's telling me is I cannot put in 90 degrees for tangent because it will spit out an undefined. And so think about like computer programming, like you're trying to program this computer so it spits out a value every single time. So we have to let it know, like, wait a minute, stop. You can't put in 90 degrees or pi over 2, whatever unit you're working with, because it will spit out undefined. If you keep going around the circle, divide this by this, it works. This by this, it works. This by this, it works. Well, 0 divided by -1, that works because that's just 0. So pi works. I divide this. Nope. Yes. This by this, that gives me some value, whatever it is, it works. Gives me a value. Uh-oh. -1 divided by 0, I hit it again. It's undefined. But if I keep going around the circle, it works, it works, it works. And again, this works because 0 divided by 1 is just 0. So what this is your domain is all reals except integers of pi over 2. Or you could put it in terms of degrees, but I'm really trying to get you used to using radians. Now I just said integers, and I want to refresh your memory. Integers are like -1, 0, 1, 2, 3, 4, 5. Like it can be negatives, it can be 0, and it can be positives, but they're not fractions. But I don't want to just say integers because if 2, so say I put 2 times pi over 2, that would give me pi, and that thing actually works. So it's actually odd integers. I'm going to make sense of this in a second, okay? I know it's a little funky. So your domain, another way to write it, and I'm not going to ask you your domain, but it's important that you know it, so when you get undefined, it makes sense to you. A little more bang for your buck, some notation. I could also say my domain is theta, such that theta cannot be pi over 2 plus n pi, I'm going to make sense of this in a second, where n is a member of your integers. So you know, a lot of us know this double R to be real. Double Z stands for integers. I'm never going to ask this on an exam, just giving you more information. So what this means is if I put in 0, okay, 0 is an integer. Well, 0 times pi is 0. Well, 0 plus pi over 2 is just pi over 2. We're here. Yep, that doesn't work, okay? If I put in 1, all right, well, pi over 2 plus pi is going to give me 3 pi over 2. And what do you know? Yep, that does not work. Okay, so it's this notation, or this written out, or this notation here is saying, okay, no matter what, you can't put in this value and you can't put in this value. Even if you go around the circle like a trillion times, these will take care of it. And it's telling, you know, you cannot put it in because your output would be undefined. Now for range, it's a little different. And again, it will get better when we start graphing. But I'm going to get rid of some stuff so it's not so confusing. So your definition for tangent is y divided by x. Okay, so that gives me something that works. Y divided by x, that works. Y divided by x, that works. But then I get here. and this gives me undefined, right? The thing is once you get closer and closer and closer and closer to this, we're going to get larger and larger and larger numbers. So, for instance, let's just pick a random coordinate. I don't want to put 1 over 0 because that's undefined. But I'm going to, totally approximate this. This is like 0.001, and then it's going to be close to 1. So I'm going to say 0.999. Randomly choosing a point that is close to this point. Okay, so I'm getting really, really close to it. This is like a calculus topic. Well, if I do in my calculator the definition, which is y over x, so I'm going to do 0.99, actually I'm going to bring up Desmos. 0.9999, I don't remember what I said, divided by, what was it, 0.001, 0.001. See how you're getting out a large number? It's almost like 1,000. Well, if I keep getting closer and closer and closer, that number gets larger and larger and larger. So what that's telling you is, and again, this might get better when we start graphing and I give you that visual, but what that's telling you is that your range is in fact all real. Because we're not putting in this stuff. So that doesn't even matter to us. But what we do put in, oh, wow, we can get really, really large, and then I could do the same approaching 0, -1. Okay, so that takes care of it for domain and range for these 3 functions that we're going to focus on.